Hello students, so today we'll start a new chapter that is functions in C++. This is from the same unit, unit for programming in C++. So in the previous video I finished on the chapter that is control statements, and from the solve exercises I have explained some programs. So there are still some more programs in the solve exercises which I need to explain. That I will explain when we perform the practical. So uh, along with that, there is another chapter called as the header file. So I'll give the format of that, so you can just go through that, and if you have any doubts on that you can ask from that also. So what is functions in C++? So this is one of the most important chapter, and if you understand this chapter very nicely, then for you the programming concept will be much clearer, because the whole basis of the C++ program lies on this function. As you have already seen one function, that is the main function. So in this chapter you'll be seeing other than the main function, other functions also. So what are functions? So functions are the main building blocks of C++ program. Alright, so this is the main building block of the C++ program. The C++ programs are built by functions. It means that, so by separating and coding parts of your programs in separate modules are called functions. So till now you have seen only one function, that is the main function, and the whole program is composed of only uh, one program. But now when we use these functions other than the main function, we separate the program, or we split the program into what is called as modules, okay, or different programs, or small programs. So we separate the program, a complex program, into modules or small programs, but all of these programs are interrelated, so that is called as functions. Now how is main function different from other functions? So the main function, it is declared by the C++ compiler but defined by the programmer. That is how the main function will be used. It depends on the programmer what will be declared in the main function, what will be the program logic that will be executed in the main function, or how, yes, so how the main functions will be processed, it depends on program by program and how the programmers write down the source code. All right, so the main function starts the execution of the program. So the main function is responsible for execution of the program, and the main function implicitly returns 0, that indicates the successful termination of the program. So whatever program it is, though even if we are using other functions, if the program is split up into modules or small programs, even if the other functions are executed, it should always start with the main function. Without the main function, the other functions cannot execute, and then after the other functions are executed, the program must always come back to the main function to terminate, because the return 0 will be written inside the main function. So the termination of the program is done with the main function. Now one main difference is main is a predefined function, that is it is a fixed function, so you cannot change this word main to say like MIAN. It is not possible. If you do that, the compiler will show an error. So it is a predefined function, so the compiler exactly knows what this main function does. The other functions are user defined function names. So the name of the functions, this is the name of the function, that is main, and with this parenthesis it indicates that this main function, this parenthesis indicates that this is a function, and this is the name of the function, and this main function will execute on whatever is written within this parenthesis, like that. So the other functions are user defined, so the name of the other functions you can define it on your own, you can write down on your own. All right, so that is the difference between the main function and the other user defined functions. So now example of the function format, so how the other functions are used by the main function, right? So here you can see that this is the main function. So when we use the other functions along with the main function, so here then it is not necessary that the main function should be written at the top. The main function can the main function may be written at the middle, or it may be written at the bottom also, or it may be written at the top. But in whichever way the main function is written, the program execution will always start with the main function only, because the compiler will execute only what is written within this opening and curly braces of the main function. The compiler will not start execution with this function. So as you can see that here, void print message, okay, here this is you have a parenthesis, so this denotes that this is a function, and this is the name of the function, that is print underscore message, which is a user defined function. Okay, so this is a user defined function. So like if you don't want to use this like print underscore, you can combine print message, or you can write print underscore message ssg, like that. So it depends on the user, since it is user defined. So this is one type of function. So this function has its own body, that is within this opening and closing bracket. Okay, so this is the body of this user defined function. So you can see that this is the main function, which is one part of the program, and this is another function, which is another part of the program. So you have, this program is split up into two modules or two programs. So this is one program and this is another program. All right, so keep in mind that the compiler will execute, the main function will start the program, and then the main function will end the program. So the compiler will execute only what is written within this main function body. So if the compiler executes only what is written within this main function body, then the compiler will not execute this part of the function. So that means this function is of no use. So that means, since the compiler will execute only what is written with this function body, so something must be written here, so that it can also execute this part of the program. Suppose like you have a calculator program. So this is addition. Okay, so this is addition. So if the main function is executed here, and this addition is cannot be used, then the addition program becomes useless, right? So something must be written within the inside the main function body, which should call this and execute this program, this module. So in the function, okay, in this function chapter, we will learn what is called as calling function, call function, okay, function prototype. So the main difference between the main function and the other function is we use only three things, that is the calling function, call function, and then the function prototype. Function prototype is in the next page. Okay, we'll come to that. So what is the calling function? So here you can see that the function names are same. This is the call function and this is the calling function. So you can see that always the calling function and the call function should be same. There should be no difference between the function name. This is the calling function is also user defined function name. The call function is also user defined function name. So print message is a user defined function, which is the calling function and terminated by a semicolon. So the calling function is always written inside the main function. All right, so the calling function is always written inside the main function body, that is inside this main function body. So as the compiler will only execute the main body, right? So this program is split into two modules of program. So the calling function always is written inside the main function body, and it is terminated by a semicolon. That means once this function gets executed, termination means, so this function will terminate, because this function cannot be called again and again. So in some programs, yes, this function needs to be called again and again, which we'll learn later on. Okay, but the program must terminate at a certain point, right? So that is so that's why the this semicolon is used. So what is this calling function, and what is the purpose of this calling function, and why do we need to write this calling function inside the main function? Now this calling function is written inside the main function. Why? Is because this function calls the call function. It may or may not receive values from the call function. So this function is responsible for calling this program to execute this program body. Okay, so this program is given a name which is called as call function. So this is something like a phone call. you're dialing your friend's number, okay, and then you're calling your friend. So this is suppose your friend. So if you're calling your friend, the message, or if you're sending a message to your friend, the message is passed here. So this is the, suppose this is the number, or this is your friend's address that receives the message, so that it will execute this body, and then the message will be read by your friend, like that. Clear? So this is something like sending, calling, and then receiving. All right. So the calling function is responsible for calling this function body, this function, so that it will execute this function body. So this is the call function, and you can see that the call function is always written, okay, the call function is always written outside of the main function. Okay, why? Because you have a different function body to be executed. You have a different function body to be executed. Now it may be that in real life programs, okay, the you may have to write down different functions. Suppose like a calculator program, you have you this is a function body which will perform addition, and then similar like this, another function body which will perform subtraction, another function body which will perform multiplication. So you will have like this 4 programs outside of the main. So when the main function wants to do addition, it will execute only this part of the program. When the main function wants to do subtraction, it will execute only this part of the program, like that, right? So that way, what happens is that the compiler does not need to go through all of the program, because it will go in a sequential manner. So if suppose the calculator program is written inside the main function, and addition is done here, subtraction is done, multiplication is done, division is done here. Now if you want to do, suppose like first is addition, then next subtraction, then next multiplication, and then next suppose like division. Now if you want to do suppose like division, now since it is written inside the main function, so what will happen is that the program flow will go sequentially. So if you want to do division, but it has to bypass through all the other program logic, that is addition, subtraction, multiplication, and then finally division. So in the end result will be, you will not get the desired output. So if there is some way possible that, okay, I want to do division, so I should be able to do only division, and I want to do subtraction, so I should be able to do only subtraction. So for that purpose, we have this user defined function. So in the user defined function, or in the call function, the program logic is written which is outside of the main function. So when the main function wants to do division, it will call the division part of the program. When the main function wants to do subtraction, it will call the subtraction part of the program. And if suppose after subtraction the main function wants to do uh, add the result with the addition, it will call both the programs. Clear? So that's why there is a necessity to split the program into multiple sub programs. Clear? Into sub programs or modules, so that it will be able to execute the programs individually. Whichever programs needs to be executed, only that will be called by the main function, that will be invoked by the main function. Clear? So here the calling function is invoked by the main function. Clear? So this calling function will call this function, that is this void print message. So here the return type is void. That means this function will execute this function body, that is the call function, or it is also called as the function definition, and it never ends with a semicolon. Clear? The call function, it is always written outside of the main function, and it does not end with a semicolon, because it has a function body to be executed by the by this function print message. Clear? So now the return type is void. That means this function does not return any value to the main function. Void means it does not return any value. Okay, so here this function must pass, as you know that this is a function, and the function will execute on whatever is written within this parenthesis or on this function body. So since there's a simple cout statement, okay, since there's a simple cout statement, that is this is user defined function body to perform program logic. So the call function will not return any value as only cout statement is executed. So this cout statement will be executed within this function body, and nothing will be returned to the main function. After execution of this body, this particular after this semicolon, this particular function body will terminate, and then so that's why the return type is void. No value is returned back to the main function. Clear? So it will come back to the calling function, and after the calling function there's a semicolon, and so it will execute the next line statement, and then the main function will terminate. Clear? So always remember that in this function chapter, what we have to learn is that other than the main function, there is always the calling function, the call function. That is, the calling function will call the call function, that is the other program written outside of the main function, and then we have what is called as the function prototype. Clear? So go through this small program very nicely, understand the concept of this. Okay, so always remember that the calling function is written inside the main function. Why? Because we need to execute the other functions which are written outside of the main function. So using the calling function only, the main function will invoke this calling function, and then the calling function will call this call function, which is the function definition, which is where you declare this function and then you execute this function body. Clear? So if the return type is int here, that means something is written inside this function body which will be returned back to the main function. Clear? And then the calling function will evaluate on that, and then you will get the output in the main function. Clear? So now let's look at what is function prototype. So function prototype is also very important when we discuss about this user defined function. So function prototype is a function declaration that specifies the return type and the data type of the arguments. So the format is return type, function name, which is the user defined function name, and within the parentheses this function may pass an argument type and argument name. Okay, so function prototype is actually nothing but similar to a variable declaration. Before we use a variable, we declared it as like int a or like int sum, like that, right? So what are we doing? We are declaring the variable, so to tell the compiler that this variable sum is going to be used inside the program, and its type is of, and it will store the integer type or float type, like that, right? So similarly, the function prototype tells the compiler that it is declaring a function with the function name and this return type. Suppose it may be integer, it may be the return type, it can be of any data type, that is void, integer, float, double, etc. Okay, so the return type of this function. So here this function name is a user defined function name. Yeah? So it is telling the compiler that okay, the name of the function, and then the return type, and then the argument type. In this case, the argument type is refers to the variable data type. Okay, so you may declare as many argument type as you want, which is separated by commas, or as many argument names as you want, which is also separated by commas. Okay, so this function can pass as many arguments as you want. So in this case, actually, okay, the arguments are called as the values. Okay, and we refer to the variable here in this function chapter as by the name parameters. Okay, so here as mentioned, this format is, so this is how you declare a function. The return type, which can be any data type, void, integer, float. In the previous example, we saw that the return type was void. So the function name, any user defined data type, which is used to identify different functions in the program. So in the program, you may have many different function names also. So all these function names are identified by this user defined function names. Clear? So we may use many different functions also in the program. So we may use more than one, we may use two, we may use three. So in order to differentiate the one function from another, the user defined function name is used. So so this user defined function name, okay, it will execute, or it will execute on what is written within this parenthesis. So here, if any information is passed to the function, so if any data or value is to be passed to the function, an argument type or parameter type, okay, so followed by argument name or parameter name should be given. Clear? So argument type can also be, this data type can also be void, integer, float of any data type. So here, actually here, argument type refers to the so here it is usually included at the start of the program. So this function prototype is usually declared before the main function. Okay, so above the main function, that means after the header file, this function prototype is written. Okay, and then to inform the compiler that the data type and the name of the parameters or variables that is used. So the parameters here represents the variable data type and then the variable name. Clear? And then the argument here represents the values which this parameter or the variables will store. Okay, so here you can represent this as parameter type or parameter name. Okay, so the parameter type means the type of the variable, the data type of the variable, and the parameter name. In this case, when we talk about the parameters, we are referring to the variables. So in function chapter, the variable is given a different name which is called as parameter, and the value that is stored inside the variables, we call it as arguments. Clear? So if suppose 10 here, if 10 is stored in suppose like variable a, so variable a is called as parameter, and the value 10, the integer value 10, is called as arguments. Clear on that? Okay, so now the main purpose of the function prototype is to prevent error mismatch between the values passed to a function and the type of value function is expecting. Clear? So the values that is passed to the function, clear, and then the type of value the function is expecting, that means the return type. So the return type, now the priority is given to this return type. Clear? So even if this suppose if this the return type of this parameter is suppose like integer, okay, so integer a, so that means a will store the variable 10, but when this value is returned back to the function, if suppose the return type of this function is float, okay, then you will get the output as suppose like not 10 plus suppose like 10.0, because the return type has higher priority over the parameter type. Clear? So it is to prevent error mismatch between the values passed to a function and the type of value function is expecting. So later on you will know that to prevent error mismatch is when we use the function calling function and the call function, we can see that the depending on the function prototype, the calling function and the call function names are also same, the return type is also same, and if there's any argument type or argument names or parameter type or parameter names, that also will be same. Clear? One thing that you need to know about the function prototype is, okay, you can pass many values to a function by argument types and name separated by commas. Clear? So which means that if you suppose you may declare here say like two variables, int a and then int b, but they will be separated by commas, like int a comma int b. So that means you are passing the variables int a and int b separate by commas by this function. Clear? So you can declare as many or you can pass as many parameters or variables as you want. For the time being, I'll just use the word variables for the word uh, parameters. Okay, I'll be using that interchangeably, so you get used to that. Okay, parameters means the variables, arguments means the value stored in the variables. Okay, so you can declare or you can pass as many here parameters as you want, as long as it is separated by comma. Clear? So the priority here is that the return type has higher priority over the parameter type. That is one important thing. Okay, another thing that you need to know is that uh, the when we come to the calling function and call function, okay, the parameter type, the parameter type the name of the parameter type, okay, does not matter. What matters is the parameter. The name of the parameter does not matter. What matters is the parameter types should be same. Clear? So that we will learn in the later videos, okay, one by one. So there is a lot of things, minor details which you need to know in function prototype, okay. The main concept of function prototype is only calling function, call function, and function prototype. But within that, okay, there are lots of topics which for which you need to know all of those one by one. So like I said, if you understand this function chapter very nicely, okay, then the C++ programming will become very easy for you. Clear? So now a program to demonstrate a simple function prototype declaration. So here you have the header file declaration. As you can see here, void sum underscore num. So this is the user defined function name, and within this parenthesis, as you can see, that this is a function prototype, and the function prototype also ends with a semicolon, and it is written uh, before the main function, just after the header file. So this is a function prototype declaration which is telling the compiler the return type. So the return type in this case is void. So this that means this function does not return any value. The function name is sumnum. So this is telling the compiler actually that the call function, this is the call function, okay, because as you can see that it is written outside of the main function. So this is one part of the program or one module, okay, and this is another part of the program, the main function program. So this sum of two numbers program, this is sum of two numbers program, this sum of two numbers program is split up into two parts. This is the one part of the program, and this is another part of the program. Clear? So this function prototype is telling that the return type, as you can see here, the call function return type is also void, okay, and here this is the calling function. So the calling function also, the return type is void here, but it is not mentioned here. So the function name, that is the function name in the function prototype declaration, the function name is sum underscore num. So you can see that in the call function and the calling function also, the function names are same. It cannot be different. Clear? So this is what a function prototype does, and you can see that within the parentheses, no parameter type is mentioned and no parameter name is passed by this function. So that means this function does not accept any parameter, or does not pass uh, any arguments. Clear? So in this case, you can see that in the call function also, no parameters or no arguments are accepted or passed, and in this case, in the calling function also, there are no parameters declared here. Clear? So the function declaration, with the help of the function declaration, we can know what will be the how the function call function will be structured, and how the calling function also will be structured. Clear? So with that we can know that, okay, so this is to prevent error mismatch. Suppose in the function declaration you have written here void sumnum, and in here you have written in sumnum, and in here suppose like you have written sumnum without this underscore. So the compiler will not understand what is, will detect error, and it will not understand what is sumnum without the underscore, and it will also not detect it will also show an error when this is written in sum underscore num, because the function prototype shows the return type should be void, not int. Clear? So that is the use of the function prototype, simply like a variable declaration. Clear? So now, so you can see that this is the call function, okay, which declares the function body, that is this. So in here you can see that the variables are declared, the variables are assigned the values you enter from the keyboard, and the formula logic is executed here, and the cout, the sum is produced, output is produced here. So that's why the return type is void, because this function does not return any value back to the main function. Clear? So now this is a separate part of the program which is not inside the main. Now if this program, this source code is written inside the main function, then there is no need of the calling function and the call function, and there is no need of the function prototype. But because this function body is written outside of the main function, so that's why we require the calling function, the call function, and the function prototype. Clear? So you compare this program with the earlier programs, that is the sum of two numbers, which was written inside the main function, and then now which is written outside of the main function. Okay, but here the main function is written below the call function, but no matter how where it is written, okay, the program execution will start with from the main function. So when the compiler starts execution inside the main function body, the calling function is written, so that the calling function will so that the main function will invoke this calling function. And this calling function, when the compiler encounters this calling function, then the then what will happen is that the compiler will temporarily come out of the main function. Okay, the control will temporarily come out of the main function in search of this same function name, clear, outside of the main function. So it will temporarily leave the main function and in search of this same function name with this same parameters, clear. So it goes in search and then it finds in here, that is the call function. And so when it finds this call function, then the call function will execute this function body, clear. So you can see that here inside this function body, just like a normal C++ program, you can declare the variables here. So here sum is initialized, and then you can enter the value here. So the value of A will be stored here, the value of B will be stored here, and then the sum formula is executed. So A plus B value is stored in the variable sum, and then using the C output stream, the value of sum is displayed here. And since C out, the sum variable value is displayed in this function body, so the return type is void, since no value is returned back to the main function, clear. So after this is done, okay, the control comes back to the closing braces, and then the control comes back to the calling function, it sees the semicolon, and then it moves to the next statement, that is the return 0. So that will successfully terminate the program, clear. So here in this program, try to understand this program nicely. Okay, so here you can see that the function prototype, the calling function, they have the same name and the type and number of arguments. So in this particular program, you can see that no argument type or argument name, or no parameter type or no parameter name is passed by this particular function, clear. So always remember that the main difference between a normal C++ program and this program is that you have a calling function inside the main function, you have the call function which contains the function body to be executed, the formula logic of that particular program, and which is written outside of the main function, clear. And then you have the function prototype, which is written after the header file before the main function. And then the function definition, or the call function, it never ends with a semicolon. Okay, the call function ends with a semicolon, clear. So this is just a simple program, okay, but whenever you want to do complex program, real life programs, okay, where the length of the program is maybe like 10-20 pages, right, then it is not possible that all the programs will be written inside the main function. In that case, the main function will execute the program sequentially. So then you need to write down, you need to split the program into small modules, and then the purpose of the main function is to call those programs only. Okay, so here the purpose of the main function is to invoke this calling function so that it will execute this call function or this function definition body, clear. Okay, so go through this program nicely, okay, and if you have any doubts on this program, you can ask, clear. So this is the simplest of the function program. Okay, now as you can see here, represented by the arrow symbol, the direction. Okay, so first when the program execution will start from here, the main function, clear. After that, okay, once it goes here, okay, once it goes here, the main function will invoke this calling function, and then the calling function will temporarily leave the main function and then goes in search of the call function, which is finds here. And then after that, this function or method body, okay, in other programming languages the function is also called as method. Okay, so this function body will be executed once this call function gets invoked. Okay, so this function body will get executed, and after this gets done, okay, control will come back. Okay, the function body execution ends, the control will return back to the main function, okay, and then execute the next statement, that is return 0. So this is a simple program, okay, where the function has no return type and it has no parameters passed. Okay, in the next program we will see another program where, okay, the function has a return type and the function passes parameters and it accepts arguments. Clear? So go through this program nicely, okay, and then try to understand the concept of the calling function, the call function, okay, and then the function prototype, and how the program process goes from one to the other. Clear? So if you have any doubts on this, you can ask me based on these programs. Clear? So that will be all for today.